In this video, we're going to review the solutions to the Unit 4 multiple choice test. Question number 1 says we have an LRAM, a left sum, with 4 equal subdivisions is used to approximate the area under the sine curve from 0 to pi. What is the approximation? Well, from 0 to pi, if we cut that into 4 equal subdivisions, that would be pi over 4, pi over 2, 3 pi over 4, and pi. And so I just wanted to draw myself a picture here. And of course, an LRAM is using rectangles. And so if I want to draw the first rectangle, it's the left corner that intersects the curve. And of course, you know your sine curve does this thing right here, that little S shape. So the first rectangle is actually going to have a height of 0. Well, the second rectangle will have a height of, if we figure out what the y value is at pi over 4, that's going to be root 2 over 2. And then the y value at pi over 2, if you think about your unit circle, the y value is going to be 1. At 3 pi over 4, remember that's going to be over here, and so that's going to be also root 2 over 2. And so the answer is C. Number 2, we have a truck moves with positive velocity v of t from time 3 to 15. The area under the graph, y equals v of t between 3 and 15. Okay, well, if we think about this integral from 3 to 15 of v of t dt, the units of v of t are distance over time. And of course, d of t, that's your change in time. So your time cancels and you're left with distance. So we're looking at the total distance traveled from 3 to 15. In number 3, the integral from 2 to 5 of f of x dx is 18. And then it says 2 to 5 of fx plus 4 dx is equal to, well, if we're going to take the antiderivative of 4, that's going to give us 4x evaluated from a 5 to 2. And so 4 times 5 is 20, minus 4 times 2 is 8, and that gives us 12. And so if we know that that's first integral from 2 to 5 is equal to 18, 18 and 12 is 30. In problem number 4, we have the integral from 3 to 7 of f of x dx is 5, and from 3 to 7 of g of x dx is 3. Then all of the following must be true except what? So this is just a problem that reviews the properties of integrals. We did not have a property with multiplication. We can add, we can subtract, we can multiply by a coefficient, but we did not have a property for the multiplication. In problem number 5, we have an integral from 2 to 5 of f of x dx equals 12, and 5 to 8 of f of x dx equals 4. Then which of the following must be true? Okay, just another practice of the integral properties. So from 2 to 8, if we just added those two integrals together, that would give us 16. And in answer E, that's the same thing. It's still going from 2 to 8, and so we'll get 16 as well. When we subtract the two integrals from 2 to 5 minus 5 to 8, well, we can subtract. And since that is multiplied by 3, that would have 12 minus 12 because 3 times 4. And so that equals 0. In answer C, they just reverse the limits of the integrand, and so it just negates. And so this is the only one that's not going to be true. In problem number 6, from a to b of f of x dx equals a plus 2b, then the integral from a to b of f of x plus 3. Okay, so this one's similar to the previous problem where we need to find the antiderivative of 3, and so that's 3x. And so we're going to be subtracting b minus a, and so we'll substitute that in. And so a plus 2b, that is your integral from a to b of f of x, plus, and then after we've substituted in the b minus a into the 3, combine your like terms and we have 5b minus 2a. In number 7, it says, suppose f prime and f double prime are all positive. And so I made some little notes for myself. I know this is going to be above the x-axis. I know I'm increasing my slope, and it's concave up if they're all positive on this interval from a to b. Suppose we compute the left, right, and trapezoidal sum, t, of the integral from a to b of f of x dx using the same number of equal subdivisions. Which of the following is true? So it's above the x-axis, it's increasing, and it's concave up. Well, then a left will be less than the integral, which will be less than a trapezoid, which is less than the right. The right will give us the largest area. In number 8, the function f is continuous on this closed interval from 2 to 14 and has values that are given in the table below. Using the subdivisions 2 to 5, 5 to 10, 10 to 14, what is the trapezoidal approximation of the integral from 2 to 14? All right, and so that's just finding the area of each of those trapezoids. And so your base in this case is 3 units. Here are your two, right, let me think. It's base 1 plus base 2. So these are your bases. Divide by 2 times the height. The height in this case would be 3, and so that's what I have here. And then these two would be your bases. Divided by 2, we're finding the average of those bases. And then the height here would be 5. And then the last one, these two are your bases, and the height of that trapezoid would be 4. If we do the calculations, it gives us 150. In problem number 9, we have the integral from 1 to 4 of 1 over square root of x plus square root of x dx. And so I rewrote with rational exponents. That's x to the negative half plus x to the 1/2 dx. If I differentiate, so I'm going to add 1 to the exponent and divide by that value. And then I'm going to evaluate from 4 to 1. It's just some fraction work here. Plug it in, and we should get an answer of 20 over 3. You can pause the video and check out my little scratch work on that one if you like. Number 10, we have an average value, so we know that's going to be multiplied by 1 over b minus a of the integral from a to b of f of x dx. And so my interval is from 2 to 6, so it's going to be 1 over 6 minus 2, which is 1/4. And it's the integral from 2 to 6 of the function. So if we differentiate and then multiply or evaluate from 6 to 2 and then multiply by 1/4, we should get an answer of 56. In number 11, we have an integral from pi to e of 2x dx. And so we just need to differentiate this. So it's going to be 2x squared over 2, and then evaluate it from e to pi. And the 2's cancel, and so it's just going to be e squared minus pi squared. In number 12, the height of an arch in feet above the ground is given by the function y equals 10 sine x between x's between 0 and pi. What is the average height? So we're looking at another average height over this interval, so it's going to be 1 over b minus a, or 1 over pi minus 0, of the integral from 0 to pi of negative 10 sine x. If we differentiate and then evaluate from pi to 0, and then multiply by that 1 over pi, we should get 20 over pi. In 13, it says if g of x is x squared minus 2x plus 3 and f of x equals g prime of x, then the integral from 2 to 5 of fx dx is equal to what? And so if I know that, let's see, the antiderivative of f of x is gx. And so what I did over here is I made myself a little table. If I know that g prime of x is equal to f of x, and this is asking me for the antiderivative of f of x, so that would be capital F. Well, that would be the antiderivative of g prime, which is g. And so then we're just going to evaluate g of the upper limit minus g of the lower limit. And if we plug that in, that's 5 squared minus 10 plus 3 equals 18 minus 3, which is 15. And problem number 14, the table below gives the weight of a child as recorded on his birthday, t years after his birth. Approximate the rate of change at 8. And so we'll take two values on either side of 8 and just find the rate of change, which is 10.5. And question 15, if a left Riemann sum over approximates the integral from 0 to 5 of g of x dx, and a trapezoidal under approximates the integral, which of the following could be the graph? Okay, so we want a left Riemann to over approximate. We can see on A, that's going to under. So C and D will both give us an over approximate with a left Riemann, and then we want to a trapezoidal under approximate. So which of these is going to under approximate? And we can see that that's C. It looks like D would probably be very close to the actual amount.